Well, hello everyone. This is KP the Math G. I'm getting ready to go to the Y and kind of letting my wife know it that I'm going to do this video quickly. This is a 2010 free response question number 2, part C and D. Now we go to the Y to work out, and I usually work out 4 times a week. Only got one day in. If I can get in today, tomorrow, and the next day, that'll be my 4 days. So that's what I'm working on. Okay, getting back to our problem. Free response question number 2, part C and D. Parts A and B I've kind of left alone because I have many videos on those. If you want to see one again, make a comment. If you say, KP the Math G, I'd like to see A and B on free response question 2, 2010. I said, okay, we can do that, no problem. Here's a table of entries, whatever entries they are. Start at noon at t equals 0 to 8 p.m. These are the entries here, and so we're going to look at part C. It says at 8 p.m. right here, entries are processed. All right, so whatever that means, they're processed. Okay, at a rate p, where p at t is equal to t cubed minus 30t squared plus 298t minus 986. This is hundreds of entries per hour. Alright, they are processed at a rate. This is the rate right here. That's a comma, that is not p prime, okay? Alright, that is a comma. P at t. Now, how many entries? And once again, when you see that, let me get this straight now. Once again, I hope this pen writes. When you see, I see the word rate right here. Where is that? Where's that word rate at? Rate. All right. Well, now how many? How many? Now when I see that, now it says has not yet, okay, been processed. Well, at t equals 8, we already have 2,300 entries, all right? That's hundreds of entries. So 2,300 that are out there. Okay, now we want to take away from ever how many has been processed, and that's what we can do. We can look at, well, how many have been processed. We can do it that way. Let's see, how many have been processed? Well, we can take the integrating from 8 to 12, because there's our, starting from, this is after the entries, this last entry is at 8 p.m. So now they're going to start being processed. Oh, they're going to be up for a good few hours doing that. All right, so so this is going to be p at t dt. I'm not going to try to attempt to show this on my calculator, but you can hit this, get up in there, either y0 or y1. All right, like that, and you can put this function in there like that. All right, and then once you get in there, you can say that in mine I can get into y bar. Now I know you might get into bar and then y bar. Okay, scroll over to y bar, and then, but you want to get the integration symbol first. All right, from 8 to 12, and then if this p at t happens to be y1, then what you can do is it will probably look something like this. 8 to 12. Once you get into y bar and then you put this in there, this will look something like this. y at 1, okay, y at 1, b dx, whatever that is, okay. Alright, like that. And it will come up. You will get an answer once you do that. I don't know if it puts it in a bracket or not, whatever, okay. And this may be in a bracket as well, I don't know. Depends on your calculator, I guess. Now some start at y0. If you put this in, whatever you put this in at, okay, y1, y0, that happens to be p at t, all of this, put all of that in there, okay, and you will get that right there. And this comes from y vars. That's where, at least it does on my calculator, okay. Calculators function a little differently than others, and so this is where I get my y vars. I just put that in there, and once I enter that, that equals 16. So anyway, if I look back here of the number of hundreds of entries, 23. You don't have to write out 2300, but it is in hundreds. So 23 hundreds that have been, you know, of all the entries, minus those that are processed. Alright, this is 16, so you're going to get 7, that's 7 hundreds, so I'm going to put the answer right here, 7 hundreds, entries that are not processed, not yet processed. Alright, so all of them minus those that are processed, there are those that are left that are not processed. And so you got to be careful with this one. You're not looking for those that are processed, you're looking for those that have not yet been processed. So the total beginning at t equals 8 is 23. That's where you get it from this chart here. Alright. Alright, so e at 8, whatever, which is 23, minus the antiderivative of p at t dt from 8 to 12. Alright, and that is that one right there. Okay, now the second one is a good one, and I may need to flip the may need to go back and forth on this one, so I kind of wanted to get this out of the way here. But now again, how many? This is the rate. Take that antiderivative or the definite integral of that rate from 8 to 12. That's how many entries you have. Look up here and see how many you have in all. Subtract the 2, and you should have the final answer, which is 7 hundreds of entries. Alright, that should answer part C. Part D, well, we're just going to go back and forth with this, I guess. Let's see what it says. Alright, part D. What does it say? Okay, now this one is, according to the model, part C, at what time were the entries processed most quickly? Okay, now most quickly. Okay, alright, most quickly means that I need to find a max. That's the key to understanding this question. Well, if I'm going to find a max, and actually it's going to be an absolute max. Absolute max. Which means that we use the extreme value theorem. So we got to worry about T and P at T. Alright, we do need the endpoints. Now remember, the endpoints are from 0 to 12. No, I'm sorry, that's wrong. 8 to 12. 8 and 12, that's from the last problem. Alright. And they're not being processed till T equals 8. Alright, and ends at T equals 12 at midnight. Then now we got to find some critical numbers, which means that when we look for max, what are we supposed to do? Alright, whatever P at T is, I'm going to go ahead and just write it down from this side. We said it was T cubed minus 30T squared, okay, plus 298T. And boy, I tell you, they wanted us to come up with a decimal. You're going to find that out in just a moment. Alright, now, and this is what I did to kind of, okay, so we need what we call critical numbers. So that means that P prime at T, the derivative of that, has to be equal to 0. If you get this, you may even get a point for showing the graders that you understand this. P prime at T needs to be equal to 0. So now I need to find P prime at T. P prime at T is equal to, this is easy enough, 3T squared minus 60T plus 298. Boy, they would have to have that. Oh, 298. See, this is 3 goes into 3 and 60, and 3 won't go into 298. Unfortunately, it will not. I did it by, I solved this by, you can do, well, several ways. You can use the quadratic formula. You can complete the square, which I did, but you can graph this. So if you want to put this in, say, y equals or y sub 0, or I think I put mine as y sub, I forgot what I put mine in. Anyway, y sub 0 I think I did. Let's see, y equals, yeah, okay, yeah, and I've got y sub 1 also. What I did is I put this right here in y sub 1, and I put this one right here in y sub 0. So I made y sub 0 P at T, which I'm not going to write all that out, and y sub 1 I made P prime at T. And I do know that if I can figure out where this crosses the x-axis, and it crosses at 2 places, by the way, that is where my critical numbers are. Here, I would have to find out where if I did just this one, I'd have to find out where my maxes are. And you could do it either way. I mean, there's going to be 2 maxes. Okay, one's going to be probably a little higher than the other, like that maybe. Alright, something like that. But, see, this is a max here, and this is a max here. But what I did is I just graphed this. This is a parabola, a little bit easier to look at. So I found the zeros. That means where they intersect the points intersect the x-axis or the t-axis. T for time, whatever you want to do. So I found the zeros, and this is what I came up with. I did on the second one graph, and there it is over here. I don't know if you can see that right there. Let me show it up to you up close. There is the graph there, okay, like that, and you can see that there's one part that's between 8 and 10 crossing the x or t axis, and then one after 10. So what I did here was I did root, and immediately when I hit the word root, mine is able to do that. I get the numbers right away. Alright, so when I did this, then I got two answers here. Where they cross the x-axis, I hit the word root. That's what a root is. That's where it crosses 0, root, same thing. Some of them may have 0 here. I don't know, the zeros or the root. In this case, x equals 9.1835. 9.1835, and then the other one was 10.8165. Okay, just like that. Okay, and then once I got those numbers, these are called critical numbers right here, and these are your endpoints. All right. So you got to remember to try out every last one of them. So this is what I got real quickly. So we want to plug that back into here. So right here I want to plug it into y at 0. So what you can do is, again, that y vars will help you a whole lot. Okay. So I got y at 0. And then I just started putting these numbers in. If I plug in 8, I get 0. If I plug in 12, I get 8. Now we're looking for the largest number. We're looking for the absolute maximum. When I plug in 9.1835, I get 5.088. Alright, so 5.088. So far, this one's the biggest y value. That's what we're looking for. Y at 10.8165 turned out to be 2.911. So 2.911. So this is it right here. Alright, so that is where my absolute max. So what we're actually saying, instead of just saying absolute max, at what time at t equals 12, the entries that were processed most quickly. Alright, at time t equals 12, there were 800 entries processed, which is the most. Okay, of course, at t equals 8, we better get 0, because that's when they first start processing. Okay, that makes sense to me. All right, so somewhere about almost 11 a.m. Okay, not quite. A little bit after, much after 10. So about, let's see, Let's see here. Let's see, hold on. Now, well, sometime around 10:49, right at 10:48.99, which is about 10:49 p.m. No, that's wrong. 12 p.m. I don't know why I said that. 12 a.m. Okay, there we go. I don't know why I was thinking this would be about 10:49. This is just shortly after 9. I'm not going to even begin to figure that one out. Okay, but you just point 0.1835 times 60, and you'll get what time it was. Okay, I'm just having a little fun with that. But anyway, there it is right there. How do you write that out? Well, here's how you say that. The table will tell you. Here's what you just say. Entries. Let's put it down here. Okay. And my wife is probably saying, KP Math G, it's time to go. It is. It's getting time to go. Alright, so here we go right here. The answer is entries. Are being processed. Most quickly. At T equals 12 a.m. Alright, there it is. And you don't even have to say a.m. Just 12. Alright, there it is. You don't even have to say how many, but there it is. You might, but I think the table will show. Okay. Don't just circle it. Say the answer. Okay, write it out. Again, this is a play on the mean value, not the mean value theorem, the extreme value theorem. The endpoints, find the critical numbers, okay, and then from there, plug those back into the original, P at T, P at 8, P at 12, P at 9.1835, P at 10.8165. And you should get these answers here. Alright, and there it is. Okay. I thought maybe sometimes I give pretty much the same types of problems, but I've been looking for different types of problems that you could look at and everything, so this is it right here. Alright, I'm getting ready to sign off. I just got to slide my shoes on and out the door we go. This is KP the Math G, getting ready to sign off. This time, maybe I'll get to do my signature clap this time, because the last two times either my battery ran out or my time ran out. So anyway, KP the Math G, make sure you subscribe if you haven't. I'm getting more and more subscribers, a little at a time anyway, and I appreciate you for that. If you want to make a comment, please make a comment. Tell me something that I could have done better or something, or just say, great job, keep it up. I like those. And then maybe just say, maybe one of those thumbs up that says, oh, what do you call that? Anyway, give me one of those. That would be really good too. And I appreciate it, whether you do that or not. I do appreciate your tuning into this, and this is the main thing that I'm here. It's not about me, but it's about me helping you. So there it is. KP the Math G. I hope I've explained this well enough for you to understand this, and if I haven't, please let me know and I'll do it again, and I'll go a little bit slower the next time. We'll probably just do D if we do that. KP the Math G signing off. Ladies and gentlemen, have a great day.